Greetings to all my tech heads out there in the KevTechify Nation. And if you're new here, welcome. In this episode, we're going to be looking at server-based AAA characteristics and protocols. We'll be discussing and comparing local AAA and server-based AAA implementations, Cisco's Identity Service Engine, Cisco Ice, the TACX Plus and Radius protocols, TACX Plus Authentication, and finally, Radius Authentication. This episode is part of my series on network security. I'm Kevin, here at KevTechify. Let's get this adventure started. One or more AAA servers can be used to manage the user and administrative access needs for an entire corporate network. Now, the AAA server software can create a central user and administrative access database to which all of your devices on your network can refer to those. Now, it may also work with many other external databases. It can work with Microsoft's Active Directory. It can work with LDAP, Lightweight Data Access Protocol. Now, these databases store user account information and passwords. It allows for central administration of user accounts. Instead of creating the user on each one of your 100 networking devices, you can set it up on one server, and then you can have all your devices refer to that server. For increased redundancy, multiple servers can be implemented. And what we have here is our AAA process. So the user establishes a connection, once again, typically something like with SSH. It establishes a connection to this router. The router then prompts for the username and password. The router gets that information back and it queries the AAA servers. Once it authenticates them, it sends back and says, yep, that user is authenticated. Cisco's Identity Search Engine, which is commonly referred to as ICE, Cisco's ICE, is an identity and access control policy platform. Now, what this does is it enables enterprises to enforce compliance, enhance infrastructure security, and streamline their service operations. Now, Cisco Ice combines policy definition, control, and reporting all into one device, into one appliance. Cisco Ice defines fair use access policies and enforces compliance for all end devices, including BYOD, bring your own device. Now, several features of Ice are asset visibility, posture assessment, segmentation, guest management and secure wireless, and finally, threat containment. If you like this episode on server-based AAA characteristics and protocols, and you get value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. Doing this supports the channel, which in turn helps me bring you more great content. Click that notification bell to turn on notifications to be alerted every time I release a new episode, and there are a lot of episodes headed your way. You can also visit my website at KevTechify.com for all my details and how to get these episodes in video and podcast form. TACACS and Radius are both authentication protocols that are used to communicate with AAA servers. Here's a table, and we can see that each supports different capabilities and functionality. Now, when we look at this, we can see several things. So when we look at functionality, here on the TACACS server, it separates AAA according to the AAA architecture, allowing modularity of the security server. So allowing modularity, so you can put different components in one of the different A's. Radius, though, combines authentication and authorization. So it combines authentication and authorization, but it separates accounting. And because of that, it has less flexibility than a TACACS server. Now, what standard does it use? Well, TACACS is mostly Cisco supported. That is Cisco's That's Cisco's protocol they're hoping everybody uses. On the other end of the spectrum, Radius is an open standard. It's driven by RFCs, request for comments. The transport protocol used by TACACS is TCP, while Radius uses UDP. Transmission control protocol, that is delivery confirmation of your data. UDP is best effort. Then we have the challenge handshake authentication protocol, typically referred to as CHAP. Here, TACACS is bidirectional and Radius is unidirectional. Confidentiality. For TACACS, the entire packet is encrypted. So username, password, that's all encrypted. On a Radius server, only the password is encrypted. So if you consider usernames a secure part of your security, Radius may not be the solution for you. Then when we look at customization, here for TACACS, we provide authorization of router commands on a per user or per group basis. So we can customize down to the user or a group of users. Radius has no options for that. No options. And then accounting, the accounting in TACACS here is limited, while Radius, it can be very extensive. So there's trade-offs, and you need to understand that before you pick a solution. TACACS could be good for one company, but might not be a good solution for another company. TACX Plus, and so I'm going to make the difference. Usually a lot of times when people say TACACS, they're referring to TACX Plus in today's world, but there is a difference between TACX Plus and TACACS. TACX Plus is a Cisco enhancement to the original TACACS protocol. Now, TACX Plus provides separate AAA services. It is possible to use TACACS Plus for authorization and accounting while using another method for authentication. What we have here is the client is going to establish a connection to R2. Once again, typically it's SSH. R2, when we're using TACACS, is going to look at the AAA server and say, should we prompt for a username? Well, what happens is now the AAA server responds back and says, yep, use that username. So now R2 says, what's your username? The client then types in, this is our username. The router then forwards that username on to the AAA server. At the same time, the router says, hey, should we prompt for the password? The AAA server says, yep, let's prompt for the password. So it says, yep, prompt for it. The router then prompts for your password and says, what is your password? You reply back with your password. The router forwards it onto the AAA server. AAA verifies username and password, and then it either accepts or rejects it based upon if you have the right combination or not. Radius is an open IETF standard AAA protocol. Now, it's for applications such as network access or IP mobility. Radius works in both local and roaming situations and is commonly used for accounting purposes. The Radius protocol hides passwords during transmission using a rather complex operation that involves MD5 hashing and in a shared secret. However, the rest of the packet is sent in clear text. Now, Radius combines authentication and authorization in one process. So what happens here is after the user establishes a connection, R2 says, what's your username? So the client sends the username. Once R2 has the username with Radius, it says, okay, what's your password? You send back your password. Now that it has both the username and a password, it will send an access request, and part of that access request is both the username and password onto our AAA server. The AAA server then processes it, and if it's good, it sends back an access accept message. And once again, this is where it combines authentication and authorization. It was my pleasure to provide you with this wonderful episode on server-based AAA characteristics and protocol. If you like this episode and you got value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel and click that notification bell. All my socials and contact information are on my website, KevTechify.com. You can get all of these episodes in video and podcast form. In the upper right is my playlist for my series on network security. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode on my series of network security. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.